Hi, my name is Josh. In this video, we'll be working on a Bernoulli problem. So this is a typical Bernoulli equation right here. So we have here some dy dx plus some function p of x times the independent variable y is equal to some function p of x times the independent variable raised to the n power. Here we'll be using a substitution where u is equal to y 1 minus y to the power of 1 minus n. So this is the problem we'll be working on, and I have the steps listed here that you can refer to throughout the video. For brevity, I'll be skipping through a few steps of the problem. So looking right here, we're going to multiply this entire equation by y to the negative 1/2. That will leave me with dy dx plus y is equal to y to the negative 1/2. Won't cover the algebra steps there, but just distribute it out. So from here, we can use our u is equal to y to the 1 minus n substitution, where n in our case is this power right here, this exponent, which is negative 1/2. So plugging that in, we get y to the 1 minus negative 1/2, which will leave me with y to the 3/2. So I have one thing here that I'm going to use, one substitution, which is u is equal to y to the 3/2. And also, solving for that other side, we get that y is equal to u to the 2/3. Right? So I'll be using these two substitutions here. So let's go ahead and take the derivative dy dx right here. So dy dx of the second one right here will be equal to 2/3 u to the negative 1/3 du dx. All right, so now I'm going to go to this equation and begin to make some substitutions. So I have dy, this is another substitution. So anything with a star will just end up being a substitution later on. So this first substitution I'm going to make, we'll get rid of this derivative and leave it in terms of u and x. So I'll have 2/3 u to the negative 1/3 du dx. So that right there is what dy dx is representative of. Plus y is equal to u to the 2/3. So I'm going to substitute that in for y. So u 2/3 is equal to u to the 2/3, y again, raised to the negative 1/2 power. All right. So going through, I'll go ahead and simplify this out right now. 2/3 to the negative 1/2 power, or u to the 2/3 to the negative 1/2 power. These twos will cancel out, and I'll be left with u is equal to the negative 1/3. So I'll go ahead and erase that. All right, and for a moment. All right, so now, similar to the first step again, we're going to go ahead and get rid of this 2/3 u to the negative 1/3 coefficient on this du dx. So we're going to go ahead and divide that out. So 2/3. Actually, we can go ahead and multiply it again. So I'm going to multiply this entire equation by 3/2 u to the 1/3. So that'll get rid of that. So I'll be left with du dx plus, then I'll have u to the 2/3. I'll actually have 3/2 u is equal to, and then this these u's right here will cancel out, so I'll just be left with 3/2. All right. Now we have a integrating factor situation. So we can go ahead, we've reduced this Bernoulli equation to an integrating factor differential equation. So right here, the coefficient will be what we'll be doing. So we have mu is equal to e raised to the integral of 3/2 dx, which will give me e to the 3/2 x. Alrighty. Now multiplying this integrating factor to this entire equation and all its elements, So we know that essentially we're going to end up with e to the 3/2 x times, oh, it's really messy, e to the 3/2 x times, and then, so it's going to be the integrating factor multiplied by the independent variable, u, will be equal to, and then it's going to be the right-hand side once we distribute this right here. So this left-hand side, when I distribute it out, I'm going to write it as a product rule, as a derivative of a product rule. So this is what we're doing here. And then when I distribute it out to the right-hand side, I'll just leave that as it was. Sorry, writing sideways here. E to the 3/2 x. Make sure I'm right. Okay. So now I'm going to take the integral of both sides, and because this is d dx, so the integral with respect to, or the integral of dx on both sides. So basically, we know that from Calc 1, these two right here kind of cancel each other out. So rewriting up here, so I'll have e to the 3/2 x times u is equal to this integral down here. You can point the camera down here. All right. Is equal to 3/2, and then e to the 3/2 x times 2/3. So here we'll have e to the 3/2 x times u is equal to e to the 3/2 x. All right. Oh, don't forget plus c, because if you do, the whole problem's wrong. All right, so now we want to isolate u. So we're going to go ahead and divide e to the 3/2 x on both sides. That'll give us u is equal to 1 plus c over e to the 3/2 x. Now we're not done yet because our equation originally was with y and x, not with u and x. So this is where we'll use this other substitution here. I know it's kind of a mess on this board. I apologize. So we'll have this substitution right here. So that we know that u is equal to y to the 3/2, so we'll just go ahead and substitute that in. Alrighty. And this right here is actually our general solution. It is defined, however, implicitly, where y or x is an implicit function of y. I think I got it, or it's the other way around. And here, alrighty, so we have our general solution right here, and we'll leave it as an implicit function. And we're not entirely done, so we'll go ahead and put the y of 0 is equal to 4. So we'll get that 4 raised to the 3/2 is equal to 1 plus c e to the 0, which is just 1. So simplifying this out, we get that c is equal to 7. We can now rewrite our solution as y is equal to 1 plus 7 e to the 3/2 x, all raised to the 2/3 power. And this right here is the final solution.